Welcome children. So we are here with the second video on probability, and here we are discussing type 2 questions of our website examprep.world, and these questions are basically on theoretical probability. Our previous video was for experimental probability. This is theoretical probability. Okay, so let's go ahead and see questions. So we'll try to understand. I've selected some 5 questions after the exercise which I have given here. Let's try and do those questions. You will understand how we have to solve them and you will be able to do on your own. Okay, let's begin question number 1. Determine the probability that a randomly selected 3-child family consists of all the boys, girls, boy, girl, girl. So they have given a different scenarios, right? A 3-child family can have boy, 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 or a boy, girl, boy, girl, boy, girl, boy, girl, boy. So many possibilities are there. So unless or until we know what are all the possibilities in 3-child family, we will not be able to do these kind of questions. So first task is we have to keep a table of all the possibilities. So there are 2 ways of doing it. One is random way where you can actually think boy, 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 girl, boy. But how many possibilities you can create? There should be total 8 possibilities. Why? Because either it's boy and girl and there are 3. So 2 cube is 8. So let's figure out. The best way of doing this is a tree diagram. Okay, I will show you how the tree diagram works. So when first child comes, either it is boy or a girl first, and the probability for this is half. Second child comes, either again it is either boy or a girl, boy or a girl. Third is also boy, girl, boy, girl, boy and girl, and once again boy and a girl. Now with this tree diagram, it's very easy to set up all the possible things. Now go with one branch, B, B, B. The first thing is B, B, B. Okay. Now go in this second route, B, B and G. Okay. The next possibility B, B, G. Then B, G, B. B, G, B. Look, then B, G and G. B, G, G. You are getting it? So we are trying to list all things which are possible in a 3-child family. Now in this route we will go G, B, B. G, B, B. What happened? B, G, 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 B, B. Then G, B, G, G, B, G, 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 B, G, G, B, G, G, G. So all 8 possibilities listed. This is the way things are possible. Now, if you don't draw the tree diagram, listing these 8 possibilities takes little time and stress on your brain. So I always suggest whenever such things are there, draw a tree diagram. It's very easy to list all the possibilities. Okay. Now let's write the probabilities of each event. Because it is theoretical probability, I am going to zoom this so that okay. So let me right. What's the probability? Half. All probabilities are half, because either it is boy or a girl. Half, 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 half and half. So once we list all the probabilities, our job becomes very easy. Now, let us go to the first question. Determine the probability that all are boys. If all are boys, then we have to go in this row, B, 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 right? The probability is half times half times half. You multiply them. 1 by 2 times 1 by 2 times 1 by 8. 1 by 2. 1 by 2, which is 1 by 8. Now, theoretically also you can see how many are there. B, B, B is 1 and total are how many? 8. 1 upon 8. Working can be written as half times half times half, 1 on 8. Only one chance is there where all are boys and among 8 events, so 1 on 8. By looking at it also you can answer, or you can answer through the tree diagram. All are girls. Where? All are girls. This is again 1 upon 8. Look, half times half times half is 1 upon 8. This is also 1 upon 8. Boy, then girl, and then girl. BGG. BGG. So this is also 1 upon 8. BGG. This is there any other BGG? Boy and girl and girl. No. 2 girls and a boy. Now this has different options. Look carefully. 2 girls. 2 girls and a boy. So we have to go with this one. This route, I will use another color. BGG. This is 1. Okay. And GGB. Right. How many are there? Half, 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 1 by 8. And GGB. This route. That is also 1 by 8. 1 by 8 plus 1 by 8. How much it is? 2 by 8, which is 1 by 4. So 2 girls and a boy. The probability will be 1 by 8 plus 1 by 8, which is 2 by 8. Ultimately it simplifies to 1 upon 4. Okay. Now is there any other thing where 2 girls are there? No. Only these are the 2 things. Now a girl is the eldest. Girl is eldest in only here. So G, B, B, all the probabilities, girl is eldest. So how many are these guys? 1, 2, 3, 4. In 4 cases, girl is eldest. The second can be anything, girl or boy. He didn't ask. A girl is the eldest. So how many are there? 4. Out of how many? 8. So it is 4 upon 8, which is half. The probability of this is exactly half. Getting it right? At least one boy. At least one boy. Means it can be 1 boy, 2 boys or 3 boys. Read the word, at least. Right? So everywhere at least 1 boy is there except for this one. Here all girls are there. So the probability of this was 1 by 8. At least 1 boy is 1 minus 1 by 8. 1 minus 1 by 8, which is 7 by 8. The probability of all girls is 1 upon 8. And everywhere at least you have 1 boy, 2 boy or 3 boys. So that will be 1 minus 1 by 8, which is 7 by 8. Okay. So this is done. Please note on your own, draw the tree diagram. You will get the hang of it. When using a tree diagram, you list out all the possibilities. You will start enjoying this thing. Okay. So go ahead and I'll pause the video and write it yourself. So kids, I hope you have done this and you have also understood. Let us go ahead and do the next question. There are 4 friends, Alex, Radhika, Clark and John. They sit randomly in a row in a park bench. So basically the bench is something like this. 1, 2, 3, 4. 4 kids can sit here. Determine the probability that Alex is on one of the ends. Okay, we can definitely do this, but in how many ways you can fill these 4 benches? There are 4 kids with you and 4 seats. So what we will do, this one in how many ways you can fill? 4 ways. Anyone can sit, any one of the 4 students can sit here. Once somebody is sitting, you have only 3 students lying with you. So how many ways you can fill the second box? In 3 different ways. After 2 kids have already taken their position, you are left with only 2 kids. So this box can be filled only in those 2 ways, right? 2. And the last one obviously can only one guy and he goes and sits there. Now how many ways this whole thing can be done? This 4 times 3, 12, 24 times 1. 24 different combinations. This is also called 4 factorial. This comes in counting principles, factorial. As of now, I've explained you how that 4 factorial works. 4 times 3 times 2 times 1. The first seat you can fill in 4 different ways. After one guy sits over there, the second seat you are only left with 3 kids. So you will put either A, B, C, 3 ways. Then after 2 kids are already sitting there, third seat, only 2 different ways. And fourth one is the last guy sits there. So altogether 4 times 3 times 2 times 1. This 24 different ways you can fill it. Now we can go and do our questions. Alex is on one of the ends. One of the ends means he can be here or here. So to answer this question, we will draw once again those 4 seats and put Alex here. Once Alex is here, in how many ways? Alex is already here. Now you are only having 3 children. So you can fill it in 3 times. This is in 3 ways, 2 ways and 1 way. Total 6 ways. Right? Now let us make Alex sit on the last one. This one. This also can be filled again 3 into 2 into 1, 6 ways. So total possibilities where Alex is sitting on one of the ends is 6 plus 6, 12 ways. And how many options we have? 24. So the probability for the first question is 12 on 24. 12 on 24, which is half. The probability that Alex is sitting on one of the ends is exactly half. Understood, right? Pause the video at different stages and try to do this question. First, what we did, we found the number of different possibilities that is possible. All these 4 kids can sit in the 4 different seats on a bench. Okay. Then we made Alex sit on one of the ends and saw the possibilities in how many ways I can fill this seat, this seat, this seat. 3, 2, 1, 6 ways. And if I keep Alex on this end, again 6 ways, 6 plus 6, 12 ways. 12 ways, Alex will be on either this end or this end. And then total ways are 24. So 12 upon 24 gave us 1 by 2. So factorial concept we will do when we are doing number systems. Okay. Now similarly, can we do question number B? Radhika and Clark at our ends. So once again, we will do this. You make Radhika sit here and Clark here, right? In how many ways you can fill this? 2 have already taken places. Now 2 kids are there. You can fill in 2 ways and 1 way. So total ways 2 into 1, 2 ways, right? Then they can extend the places because they are at ends. Clark can come here, Radhika can come here. Once again, you can do it in 2 times 1, which is 2 ways. Total 2 plus 2. In 4 ways, Radhika and Clark can sit on the ends. And what is the total possibilities? 24. Probability is 4 upon 24, which is 1 upon 6. So our answer B is also done. 4 upon 24, which is 1 upon 6. I hope you understood this one. It's very easy. So just pause the video, write it on your notebook. It will help you. So I'll move away. Note this, then we are going to do C and D. Okay, children, now let's do C and D. John is on one end and Radhika is next to him. Now, John is on one end and Radhika is next to him. So if we draw that arrangement, John is one of the end and Radhika is here. Then how many possibilities? 2 ways and 1 way. This is possible 2 ways. The other 2 guys will adjust. And this time, John is on this end and Radhika is here. Once again, 2 and 1, 2 ways. Total how many? 4 ways this combination is possible. So 4 upon 24. Once again, the probability is 4 upon 24, which is 1 upon 6. Part C done? Okay. Now, Alex and Clark sit next to each other. Alex and Clark are sitting next to each other. Let's do that. I'll erase this. I hope you have noted. Alex and Clark. So let's make 4 benches. Alex, Clark. So 2, 1. Then we will do Clark, Alex. 2, 1. Alex, Clark. 2, 1. Clark, Alex. 2, 1. And then similarly you will have 4 more possibilities where you have Alex, Clark and Clark, Alex. Okay. So how many possibilities? 2, 2, 2, 2, 2, 2. 2 plus 2, 4, 6, 7, 8, 9, 10, 11, 12. There are 12 such possibilities when Alex or Clark are sitting next to each other. So this is 12 upon 24, which is 1 upon 2. Okay. So when I was calling name of Alex, my Alexa was started to respond. Okay. So I hope you understood this question. Okay. It was little long, and little challenging, but if you understand it correctly, this becomes easy. So I'll move away from the board. I want you to pause the video there and copy this one. I hope you have done this. Now let's go ahead and do the next question. In a class of 24 students, 10 are studying biology, 12 are studying chemistry, 5 are not studying any one of these subjects. We have to first represent the situation on Venn diagram. I hope you have seen my Venn diagram videos. If you see them, it becomes easy. Otherwise, still I am going to do this for you here. Let us represent. Let's make a Venn diagram. How many subjects are there? Biology and chemistry. And there are some students who definitely will study both the subjects. Biology and chemistry, will figure out. So this is biology, chemistry. Total 24 students. 5 are studying nothing. First you capture this. 5 don't study anything. So let us put that 5 here. Okay. Now once you put 5 here, from total of 24, subtract 5. So total is 24. Biology is 10. Chemistry is 12. And 5 are none. None. Right. So first we do 24 minus 5 becomes 19. That means biology, chemistry together it is 19. Right. But if you add this one, 10 plus 12, how much is that? 22. But here we have 19. That means there are some students who are studying both. 22 minus 19 is 3. So 3 students are there. So what I am doing, because I have 22, 10 plus 12 is 22 minus 19 is 3. That means 3 students are studying both. Now how many are studying bio? 10. 3 is already here inside the biology circle. What is left here? 7. 7 plus 3 becomes 10. See, inside the circle of biology we have 10 students. Now, what about chemistry? Chemistry is 12. 3 already included. So it should go with 9. Now add all these numbers, 7 plus 3 plus 9 plus 5. Is it 24? Yes, it is becoming 24. That means our Venn diagram is correct. Once a perfect Venn diagram is done, job becomes easy to answer all these questions. Find the probability that a student picked at random from the class studies chemistry but not biology. Chemistry but not biology. So height biology. And how many people are studying chemistry? 9. So answer will be 9 upon 24. And that's the simplest form. It doesn't simplify further. So first answer will be 9 upon 24. Okay. Now, both chemistry and biology, it's very, very simple. 3 on 24. Both chemistry and biology. So it is 3 upon 24. Can be simplified? 1 upon 8. 1 upon 8. The answer is 3 upon 24. 8 3s are 24. 1 is to 8. Okay. I hope you understood. The challenge was to draw a correct Venn diagram, and after Venn diagram is done, the answer becomes very easy. You just have to put that number upon the total. You get the probabilities. Okay. I'll move away. Pause the video here. Do it yourself. Guys, you have done this question now. So let's go ahead and try the next one. Oh yeah. A spinner. Here we have a spinner. It has 1, 2, 3, 4, 5 numbers on it. You can spin and see which number you are getting. No, something like casinos, right? So it's a very small spinner. Casino has a very big one, right? So this is a small thing. And you have a coin. You have heads and tails. 2 things on the coin. A coin and a pentagonal spinner with sector 1, 2, 3, 4, 5 are tossed and spun respectively, one after another. List the sample space of outcomes. How many possibilities are there? See, you can get head and 1, you can get head or 2, or you can get tail or 5. So many options are possible. So what we will do, we will try to draw a head, tail, head 1, head 2, head 3, head 3, head 4 and head 5. Then tail 1, tail 2, tail 3, tail 4 and tail 5. Is there anything else which is possible? No. Either you will get a head or a head and 1, head or 2, head or 3. So total possibilities are 5 here and 5 here. 10 possibilities are there total. So we have done the sample space is done. Our first job is done. This is a sample space. All the possible options is called sample space. Now we have to draw a grid and determine the chance. Grid is already done. A head and a 4. A head and a 4. Only one place you are having head and a 4. So 1 out of 10. So probability is 1 on 10. A tail and an odd number. Tail and odd number you have 1, 2 and 3. There are 3 places where you get a tail and an odd number. Odd numbers are 1, 3 and 5. So it will be 3 upon 10. 3 places 1, 2, 3 on 10. An even number. Do you get any even number? You get even number, but with that you are getting head or tail also, right? So this probability is 0. Because you are getting I. Is there anywhere you just have even number? You also have a head or tail, right? So just getting an even number is not possible. If you don't spin the spinner, or if you don't toss the coin and only spin the spinner, then you get even number. 3 possibilities. Not even 3, 2 possibilities, but we are doing 2 events. So getting just even number is not possible. So the probability is 0. A tail or a 3. Tail or a 3. Can you get only tail when you are doing this? Tail and a 3, yes, it was 1. But he is saying tail or a 3. But we are doing 2 events, so that probability is also 0. It is not possible that you get only tail when you toss a coin and spin a spinner. You will get a number and head or tail, right? So this is also 0. I hope you understood. Pause, write it. Okay, so let's go ahead and do next question. 50 tourists were on an adventure holiday. Okay, 50 guys. And 40 went for rafting. So first I'll try to capture data. This time I will want to use my favorite color, blue. Okay, so total number of tourists were 50. 40 went for rafting, 21 for paragliding, adventurous, right? and each tourist did at least something or the other. That means there is nobody who didn't do either this or this. Everyone did something or the other. Some may do both, some may do only one, right? So outside the circles there is no one. Now to answer these kind of questions, the best thing is draw a Venn diagram. Because when you have to find the probability, a Venn diagram will help. Now 40 plus 21 is how much? Total of this 2 is 61, but there are only 50. So 61 minus 50 is 11. That means 11 tourists did both of it. So completing the Venn diagram becomes easy. Yeah. So rafting and paragliding. So this is 11 have done both. Now 40 minus 11, 29. 29 plus 11 is 40. See, inside the circle of rafting you have 40. And what about paragliding? 21. 11 have already come here. So 10. Now see, inside the circle of paragliding it is 11 plus 10, 21. And no one is outside, we know. So add them, 29 plus 11, 40 plus 10, 50. Our total is right. So Venn diagram is right. Now time for answering our questions. Participated in both the activities. Both the activities means intersection of both the circles. 11. Okay. So let's go ahead and write the probability is 11 upon 50. This is the most simplified form. Can we simplify? No. So leave it there. 11 upon 50 is the probability that tourists did both of them. Went for rafting but not paragliding. Rafting but not paragliding. So hide paragliding because they have not done this. Which is left? 29. So our answer will be 29 on 50. Okay. Easy. So I'll move away, pause the video and do this one. So kids, you have done this. With this we come to end of these type of questions. I selected 5-6 questions, but in the website examprep.world there are many questions. I want you to practice all of them and make a note of it. So you will get a better hang of these questions, and we'll see you in the next video. Thank you.